All right, we're in section 132. As always, there'll be contents, there'll be examples, and there'll be exercises. My name is Ron Bannon. This is a draft version, my draft version, of an adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF document is being made available to the PRISM Mathematics Project participants only. In the future, it will be published. It takes some time to get there. We're not ready yet, or I should say I'm not ready yet. If you need to reach out to me, my name is Bannon. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. All right? And certainly if you reach out to me and ask me about when it's going to be published, I'll keep you updated when it gets published and where to get it. All right? So what we're doing up here, again, it's a tougher section, but we're towards the end. I mean, we're really getting very close to the last. And these are going to be reciprocal recurring equations. And they tell you what that is and tell you how to go about solving these things over here. I wouldn't worry about it so much. What I'd worry about is that, it gives sort of like rules for what to do. And that's good. But I just say, you'd probably say, do I need to memorize everything that I'm reading? No, you don't need to memorize. That's why we've written words down. You can actually go back and look at this stuff. And it's not easy. It's not easy to get through it. All right? My claim over here is, certainly after you do get through it, you want to try to understand how to do this. And I'm going to walk you through a problem. All right? Now, of course, when I'm doing these problems over here, it may sound a little bit different than the way Wells would do them. Right? So I'm going to claim over here, if I'm asked to solve this thing over here, I got to be honest with you, it could be an extremely difficult problem. It is unlikely, though. So you should start to believe that what we're giving you is doable. So if I were looking at the rational root theorem over here, right, the rational root theorem, I would be looking at plus or minus, well, this is going to be easy, the factors of 2 divided by the factors of 2. So the factors of 2 are going to be 1 or 2, and the factors are 1 over 2, 1 and 2. So what would you get over here? Let me write down the whole list. It's not that bad to write down. You get 1 and 2, and then what would you get? Let's take a look. 1 and 2 would definitely go to the other. Then you get what? 1/2. That's it. How many are there? 6. So what's the easiest one to try is 1. So I'm going to try 1. Let me get my eraser out. I'm going to see if 1's a solution to this problem over here. If it is, good. If it's not, I'll try -1. Then I'll try 2 and -2, and then I'll go to 1/2. All right, so let's write this down. All I want to do is find 1 now. And I'll go through that with you. So let's put that down. So it would be 2 minus 5. I'm testing out 1. I want to see, is x equals 1 a root? I have no idea. So minus 13 plus 13 plus 5 minus 2. Well, you know what? Immediately what am I seeing? I'm seeing that this thing over here, there's a good deal of symmetry in it. You see that? That's good news. I'm seeing that symmetry now. All right, let me get the eraser out. This is a root. Now, if it's a root, I know a factor of the problem now. So x equals 1 is the root. Let me erase this over here. I'm not going to look at the other ones, by the way. Just too much work. And I'm going to say now I know that x minus 1 is a factor. What I don't know is I don't know what remains there, and I've got to do a division. All right? So I'm going to write the division down. Let me get my little eraser out. And I'm going to write down. Yeah, I know it looks like chicken scratch, but I'm just working through it. Make sure you understand what we're doing. And you certainly should use more paper than I'm doing. But I'm going to divide by, let's see, x minus 1. And what I know about this division, it's going to go really smoothly. Let's put this down. 2x5 minus 5x4 minus 13x cubed plus 13x squared. And I really believe that you can see symmetry now. All right, let's take a look at it. What are you going to get? Well, it's going to be 2x4, right? What does that give me? 2x5 minus 2x4. Well, I'll put a little line here. I'm going to do my subtraction. And what do you get? You get minus 3x4 minus 13x cubed plus 13x squared plus 5x minus 2. Let me repeat this. I know the division is going to go smoothly. If it doesn't, I'm doing something wrong. Let's put the next term down. That's going to be minus 3x cubed. And what do you get there? Minus 3x4 plus 3x cubed. What do you get there? Minus 16x cubed plus 13x squared plus 5x minus 2. Let's keep repeating. Minus 16 now. X squared. What do you get? Minus 16x cubed plus 16x squared. What do you get there? Minus 3x squared plus 5x minus 2. Let me repeat this. If division's not working out, I made a mistake somewhere. Let's take a look. I'm going to say minus 3x now. What do you get? Minus 3x squared plus 3x. And what do you get there? 2x minus 2. Oh, 2. Look at that. Remainder 0. Remarkable. It really is. Look at that. A lot of symmetry there too, huh? You see, let me point out what I mean by that. 2, 2, 3, 3, 16. All right, I see it. All right, so what I'm going to do is, what do you do with that now? It's a depressed. I'll write this down for you. I took this guy here, and I got a linear factor, and that was x minus 1. And now I got this depressed quartic. It's a fourth degree. 2x4 minus 3x squared. I'm sorry, cubed. Minus 16x squared minus 3x plus 2 equals 0. Now what we're going to do is, it seems tricky, but what we're going to do is we're going to divide through by x squared. Now, someone's going to say, what gives you the right to divide by x squared? I know x isn't 0. Let me erase this chicken scratching aside now. And again, these are things that you shouldn't be, at this stage, learning these things. You know how to divide now. All right? You're not trying to prove to someone you know how to divide. It's really something, it's an old topic. All right? So I'm going to divide that second factor by x squared. I want to point out what I mean by that. We're dividing this thing by x squared. Well, let's see what you get. You would get 2x squared minus 3x minus 16 minus 3 over x plus 2 over x squared. And I'm dealing with this factor here. And really, it looks crazy looking, but let me put this over here. I want this, again, I know x is not 0. I want this to be 0. I want that to be 0. All right? Here comes the tough part. And I'm looking at it. You know what I'm going to do? I'm going to take this one and this one and bring them together. They're both squares, right? So let's write that down. 0, 2x squared plus 2 over x squared. And then I'm going to bring these two terms together. And again, I hope you understand there's symmetry here. Like I'm seeing these patterns of 2, 2, 3, 3, and a 16 in the middle. Let's write this down. So minus 3x, and then minus 16. Again, I want to point this out to you. There's symmetry here. All right, seeing it. Now let's do this. Again, it may lead nowhere, but let's write this down 0. I'm going to put a 2 out there, and you get x squared plus 1 over x squared. I'm going to factor minus 3 out, and you'll see something remarkable again. It will be x plus 1 over x, and then I get a minus 16. All right, so someone can say, what are you going to do now? Well, I'm going to make a substitution. And the substitution I want to make, I don't like the look of x plus x over 1. So I'm going to say x, I'm sorry, I said x, it's 1 over x. I'm going to make this equal to u. And to do that, I don't like the look of that, and like the look of that either. So I actually have to put u squared down. I want to wonder what that looks like. Again, if you're struggling over here, I want to write down If you want to know what u squared is, it's 1 plus 1 over x squared, which is 1 plus 1 over x times 1 plus 1 over x, which isn't bad, by the way. You can I'm sorry, not 1 plus, it's x plus. That's just going to be x squared plus 1 over x squared. And then the middle term would be 1 plus 1, which is 2. All right. All right, let's take a look. All right, make a substitution now. 0 equals 2. I got to be careful here, don't I? So what's x squared plus 1 over x squared? It's u squared minus 2. Now someone says, what's you accomplished over here? I'm hoping to accomplish getting this thing to be a much easier polynomial to deal with. Then you get minus 3u minus 16. By the way, I realize some people are looking and saying, oh, your work looks different in the notes. This is just me. I like to do things differently each time I attack a problem. There's similarities, though. I'll tell you that. You know, they're using y when I'm using u. So let me write this down now. All right, I'm going to just go one step at a time. So we get 0, 2u squared, minus 4, minus 3u, minus 16, 0, 2u squared, minus 3u, minus 20. Oh boy, I got to factor that, don't I? And let's take a look. I'm going to give it a try. Let's take a look. I'm going to say, whatever I say I'm going to try, by the way. What do you get? 2u squared minus 8u plus 5u is minus... Yeah, this worked beautifully. So u is equal to 4, or the u is equal to minus 5 over 2. Now, I realize that some students want to box that as an answer. That is not an answer. That will lead to an answer, though. If someone says, why is that? We've got this over here. And my equations in terms of x's. So I'm going to write the first one down that I like doing. We'll check the key later. X plus 1 over x is equal to 4. And what's the other guy going to be? X plus 1 over x is equal to minus 5 over 2. All right, I got to solve those equations, by the way. And let's just do this one first, because it's easy for me. I'll multiply both sides by x. You'd get x squared plus 1 equals 4x. I'm going to try to solve this equation, and I'm going to subtract 4x from both sides, and I'm going to subtract minus 1 from both sides. Let's see if I did good there. Let's see, x squared plus 1. Yeah. Complete the square. Half of minus 4 is going to be minus 2. Square it, you get 4. What do you get over here? X minus 2 squared is equal to 3, or x minus 2 would equal plus or minus the root of 3. So I got some answers over here now. What answer I get from here? I got x equals 2 plus or minus the root of 3. All right? Let's do the other one. Let's do this one now. And let me put it over here. I'm going to multiply both sides by 2x. You get 2x squared plus 2. You know what? I don't like, because I'm going to run in the room here. Let me just, I'm going to take this guy, put him right here. I'm multiplying by 2x. 2x squared plus 2 equals minus 5x. Well, I'll do this one a little differently. This is 2x squared plus 5x plus 2 equals 0. We have an SQ to look at, don't worry. I'm going to use quadratic form in this one because it's easier for me to do that than to complete the square. So x will equal, I'll write all the roots down when I'm done. Let's see, it's going to be minus to b. And let me repeat this, if mistakes happen, we're going to correct our mistakes. And you should too when you're doing homework. Make sure if you make a mistake happen, you want to correct it. Let's see, b squared is 25. Minus 4 times 2 times 2. Well, 4 times 2 is 8. 8 times 2 is 16, right? And you get twice 8, which is 4. So what does x equal? Let's be careful. It's going to be minus 5 plus or minus. What would you get there? 25 minus 16. That's going to be what? 9, right? And the square root of 9 is 3, isn't it? Over 4. So what do you get up here? X equals minus 5 plus 3, which is minus 2. Minus 2 divided by minus 4 is minus 1/2. Or x would equal, let's see, minus 5 minus 3 is minus 8, divided by 4 is what? Minus 2. All right? So what I want to do is I want to say that I probably could have discovered those right from the beginning, and I'll tell you why. Do you remember we did the rational root theorem, and what I say the potential roots were? 1, 2, or 1/2. What did I test out? Only one of those, but I could have went further. So now I realize there's more rational roots. I want to write these down for you, though. All right, so I'm going to write down x. Let's write down x1. And I think remember we did that? We said 1 was a root. I'll write that down for you. I'm going to write down x2. I'm going to use this one over here because it's the simplest one I could write down. I'll write down x3. That's minus 1/2. I'm going to write down x4 and x5. What was x4? 2 plus root 3 and 2 minus root 3. All right, I'm going to put a box on it indicating I got to the end of my problem set, and I'm going to check the key now, see if we got it. And I see this. 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 I notice they're saying something about these over there, reciprocals. Let me point out what I mean by that. So I'm going to point out x1 is a reciprocal of x1. x2 and x3 are reciprocals. I'm claiming these are reciprocals too. So I want to go through that with you. And to show the reciprocals, what I'm really trying to show you is I'm trying to show you that x4, which is 2 plus root 3, is actually the reciprocal of x5. Well, the reciprocal of x5 is this one over here. Now, by the way, this looks a little strange to me, but I want to point out, let's take a look at it. And I'll multiply top and bottom by 2 plus root 3. I'm trying to rationalize it. When I say rationalize the bottom. What do you get on top? Well, 1 times 2 plus root 3 is 2 plus root 3. What do you get on bottom? You would get 4 minus 3, which is 1. Yeah, the reciprocals. Let me repeat this over here. x1 is a reciprocal of x1. x2 is a reciprocal of x3. x3 is a reciprocal of x2. x4 is a reciprocal of x5. Reciprocal of x5 is x4. They're reciprocal, all right? Again, I want to point out some things I'm noticing over here. Symmetry from the get-go, right? What else am I noticing? Solutions are reciprocals. All right, let's go back. After you do an example, you may want to go back and reread that section. It's a long section, though I realize that. Reciprocal or recurring equations. A reciprocal equation is one in which if any number is a root of the equation, its reciprocal is also its root. It follows from the above that if 1 over x is substituted for x, reciprocal equation, the transfer equation will have the same roots as the given equation. That's an important fact, by the way, if they're reciprocal. Now, of course, they go through a conversation, and you want to pay attention to that conversation. Does that mean you understand every detail of the conversation? Absolutely not. What are you doing? You're putting little tiny, I'd say, pebbles, and those pebbles will build up over time into a knowledge base, all right? To memorize, no. To understand what you're reading, yeah, you'll get better over time. All right, let me scroll through this. I want to point out, let's look over here. Look what the examples look like. We just did that. What do you do next? Well, again, after you do that one example you went through and maybe reread the notes again, you start doing these things over here. And again, what I'm pointing out over here, I'm seeing symmetry. I'm seeing symmetry in the problem. All right? Now, again, I still would do the rational root theorem on it. I would look for a root of the problem. All right? Now, what would the roots be? You know, since there's really nice symmetry over here, you know, factors of 4 over factors of 4, you could write all the possible rational roots down, but bottom line, it's not bad. I want to point out what I mean by that. What are the factors of 4? 1, 2, 4, and the factor for 1, 2, and 4. I'm just in the rational root theorem. What do you have? Plus or minus 1, 2, 4. And then what you get? Well, let's take a look. You get, 1 over 2. Let's see, 2 over 2 now. 4 over 2 now. I'm not going to put that down. Whoops. Then you get what? 4 over 1, that's in there. 4 over 2 is in there. Yeah, that's it. I got those. How many? 8. There's 8 of them. Test them out, all right? I'm going to claim minus 1's going to work. You go through that, verify it. And certainly, I'm looking at it. I'm also going to do that thing we did before, basically just dividing through by x squared then, all right? And I did that. I think over here, let's take a look. Oh, you know what? This one turned out to be pretty easy because when I divide it by x plus 1, a cubic goes to a quadratic. It's a really easy problem to do. Sorry about that. I didn't do the divide by x squared. Okay, next one up. Again, these are reciprocals, all right? Minus 4, reciprocal of that. Minus 1 is reciprocal of minus 1. Right, cubic. Again, these are pretty simple, actually. I didn't realize that. Again, I use rational theorem. You'd get it, and then I'd get a quadratic after I get that, rational root, because it's the depressed one's quadratic. It's pretty easy. These guys are reciprocal of one another, and certainly one is a reciprocal of 1. Let's see if there's anything different. No, it's still the cubics. They're pretty easy to do, by the way. And again, maybe I should start pointing this out, too. What do I notice about these guys? Again, you'll notice in symmetry over here. You're noticing symmetry. 1 and 1, minus 5 and minus 5. You're noticing symmetry over here. Again, cubic, 4th degree. This is good. So what do you do over here? Again, I notice the symmetry. I'd use rational root theorem to find a root. And I think I found 2. I think I divide through. Yeah, another quadratic one. Pretty easy to do. What am I going to notice over here? Reciprocals. All right, you notice that. These reciprocal equations. 4th degree, same deal. Make sure you look at that. I put the work down for you. Let's see if there's anything difficult. 5th degree, yeah, 5th degree is pretty difficult. I'll look for a root, divide through. You get a depressed quartic. Then I divide through by x squared. And then I made that substitution we made for the original problem. All right? Let me go back. I want to point out the symmetry on the problem. Coefficients 1 and 1, 2 and 2, 5 and 5. All right, I see some symmetry over there. All right. Yeah, 5th degree, same thing we've done before. 5th degree, nothing, I don't think they're going to be on 5th degree, are they? 5th degree. Plenty of examples for you to try. 6th degree, there's a problem. All right, I would still look for, there's going to be 6 roots to it. Again, I'm noticing the pattern, 10, 10, 19, 19, 19, 19. Let's take a look. Again, I divide through by, I guess x squared minus 1. I look for 2 rational roots over there just to make my life a little bit easier. I went through those steps for you. Quadratics, yeah, not bad. Reciprocals. And again, pay attention to what we're saying, that the reciprocal of 1 is 1, the reciprocal of minus 1 is minus 1, the reciprocal of 5 halves is 2/5. I'm expecting to see that. And the reciprocal of this root there is that root over there. They're reciprocal to each other, all right? You may want to verify that. What are you going to do now? You're going to do look at the SAGE. At least we hope you look at the SAGE. Computer Algebra System, or CAS for short. It's open source software. Go to this website. Either download the software, interactive web application. You can look at the code if you like. Again, doing Wells's work doesn't mean you have to look at the code. What we want you to do is we want you to really study Wells's work. My name is Bannon. My email address is Bannon. That's B as in boy, the @ symbol, nnon.us. Our goal is for you guys to do this work over here. Yes, we put a lot of work down. I should say, I put a lot of work down there for you. We want you to look at the work, right? But the deal about this over here, if you're solving the problems and getting the solutions, you're doing good. If you're solving the problems and not getting the solutions, you know what? Maybe I made a mistake. I'm not checking these solutions, by the way. I went through my work. I'm pretty confident. And I think I did a good job, by the way, but me thinking I've done a good job doesn't mean I did a good job. More eyes on this work, the better. All right? I'd also recommend, if you're struggling with this, please look at my work. All right? Please look at the work. Try to make sense out of it. The deal is this, though. Please, if you think there's an error, point it out to me. If you say you're in section 132.3, I'm doing problem number 4, I think you made a mistake, I will listen to you. If you do point out an error, though, and I agree with the error that you're pointing out, you will get credit. All right? Your name will go down in the document, and your name will be cited, unless you tell me not to cite your name. All right? So get to work. Thank you.